In this video, I'm going to prove that the square root of 2 is irrational. Before we start, so we're all on the same page, I'm just going to run through what a rational number is. A rational number is any number that can be expressed as a ratio of two integers. For example, 0.5 is 1 over 2, 0.7 is 7 over 10, and 0.111 repeating is 1/9. Directly proving a number is irrational is really hard, since we'd have to check the ratio of all integer pairs and show that not a single one of those pairs equals the square root of 2. Seeking a contradiction, suppose the square root of 2 is rational. Then that means there exist integers p and q such that p divided by q is the square root of 2 and the greatest common factor of p and q is 1. Note, we can add this condition since if p and q had any common factors, we could divide those factors out. Think of 5/10 versus 1/2. We can divide 5 and 10 by 5, but we cannot divide anything out of 1/2. Now we have p over q equals the square root of 2. This is something that's not too easy to work with, so let's get rid of that square root by squaring both sides. So now we have p over q squared equals square root of 2 squared, which means that p squared over q squared equals 2. Multiplying through by q squared, we get p squared equals 2 times q squared. 2q squared is even since it's 2 times an integer. This means that p squared is even. Now, we don't know anything about p. P could either be even or odd, but we know that p squared is even, and I'm going to try and convince you that means that p is also even. To convince you that p is even, let's look at the case where p is odd. So if p is odd, that means that p can be expressed as 2k plus 1 for some integer k, and p squared would be 2k plus 1 squared. Foiling this out, we get that p squared is equal to 4k squared plus 4k plus 1, which equals 2 times 2k squared plus 2k plus 1, which happens to be an odd number. Thus, we can conclude that p is not odd, p has to be even. Since p is even, that means that we can express p as 2 times k for some integer k. That means that p squared equals 2q squared is the same as 2k squared equals 2q squared, which means that 4k squared equals 2q squared. Dividing by 2, we get that 2k squared equals q squared. This means that q squared is even. By the same line of reasoning that we just went through, we can conclude that q is also even. Since both p and q are even, that means they share a common factor of 2, which contradicts our initial assumption that the greatest common factor between p and q is 1. Thus, we can conclude that the square root of 2 is irrational.